Good morning, students. Let us see here one softening method of the water is ion exchange method. Water, it consists of number of hardness causing salt. That water, it is called as hard water. That hardness, it is required to remove to use the water for various purposes. So that is one of the method, ion exchange method. Actually there are three mostly used methods for softening. One is lime soda method, second is zeolite method, and third is ion exchange method. So let us see here the ion exchange method. What do you mean by this method? It is carried out that water, hard water is softened here by using the ion exchange resin. So that's why that method is called as ion exchange method. What about the principle of this method? Actually before the principle, let us see here about the its necessity, that method necessity. Actually for the boiler purpose we require the water with zero quantity of salt present in it, whether it may be cation or it may be the anion. So that method, it gives us water with zero quantity of cations or the anions in the water, or it remove all the cations or the anions from the water which causing. So that method is a ion exchange method. That water obtained, soft water obtained from this method we can use for boiler purpose. Now then, this is a construction for the plant or that equipment which is used for this method. If you see here, this is a first tower or first column which is filled with the cation exchange resin, and the second column which is filled with the anion exchange resin. So let's see here, the first column it is filled with the cation exchange resin, and second column it is filled with the anion exchange resin. These two columns are attached with each other with the help of some pipeline. First tower, it is attached with the inlet, so that is the inlet for the hard water which is to be softened. And the second column, it is attached with the outlet for the soft water. Then these two reservoirs are attached here for first and second column respectively. So first column, it is attached here with the acid reservoir, and second column is attached with the base reservoir. It is filled with the acid like HCl, and it is filled with the dilute NaOH solution. So that about the construction and the labeling of this equipment which we have to use for such softening. Now let's see here, what do you mean by these resins which are used here? These are the ion exchange resin. What is the definition of the ion exchange resin? Ion exchange resins are long chain cross-link polymeric molecule attached with the functional group. These are attached with the functional groups. It may be acid or base, and these resins are capable of exchanging cations or anions from the water, causing hardness. So that is a definition of the ion exchange resin. What do you mean by ion exchange resin? It is long chain cross-link polymeric molecule which is attached with the functional group like acid or base, and which is having ability to exchange the cations or anions causing hardness from the water. Such resins are called as a ion exchange resin. about the cation exchange resin. What do you mean by the cation exchange resin? These are those resins attached with the acid functional group. We know the two types of the functional group attached with the resin, may be acid or basic. So the cation exchange resins are attached with the acid functional group. Acid functional group means like SO3H or it may be COOH. So resins attached with this acid functional group called as cation exchange resin. It is represented by the general formula 2RH positive. What is the meaning of the anion exchange resin? In this case, anion exchange resin are those resins which are attached with the basic functional group NH2 or double bond NH. So if such basic functional groups are attached with the resin, those resins are called as the anion exchange resin. Now these are represented as ROH negative. General formula for these resins is ROH negative, and for these resins is cation exchange resins is RH positive. Now, what is the ability of this cation exchange resin? It can exchange cations causing hardness from the water, and it can exchange anions causing hardness from the water. So let's see here how. If the hard water contains calcium, if the hard water contains CaSO4 salt, if the hard water contains calcium sulfate salt, so this cation exchange resin exchanges its H positive ion with the calcium ion from the water, and in this way the water it will become free from calcium ion. Let's see here how. For example, if such resin it is react with the calcium ion, so this RH positive, that reaction, exchange reaction, it is occurred here. So it gives here R2CH plus 2H positive. Means in this way this resin gives its H positive ion to the water and takes Ca2 positive ion from the water, and that water it will become free from the calcium ion which is causing hardness here, and that water will become salt. So that about the cation exchange resin, ability of cation exchange resin. Now let's see here about the anion exchange resin. Now what about the salt present in the water? We considered here calcium sulfate. Calcium it is removed here by using the cation exchange resin. So which salt is ion it is remained here? SO4 2 negative ion. So that SO4 2 negative ion is removed by these anion exchange resins. What about its ability? Let's see here the reaction. SO4 2 negative ion from the water, hard water, plus ROH negative, that is cation exchange resin. So in this case there is formation of R2SO4 plus 2OH negative. So in this way that cation exchange resin takes SO4 seen that first column it is filled with the cation resin. Second column it is filled with the anion exchange resin. Okay. Consider our water, it contains calcium sulfate salt or magnesium carbonate or magnesium chloride salt or calcium carbonate or magnesium carbonate. If these salts are present in the water, then that water it is called as hard water. Okay. So first step, that hard water which is to be softened, it is allowed to pass through this first tower which is packed with the cation exchange resin. That water it comes in contact with these resins and the exchange reaction occurs, and that resin it takes the cations causing hardness from the water, and at the same time that resin it gives its H positive ion to the water, and it takes Ca2 positive ion from the water or Mg2 positive ion from the water. So how the reaction it is occurred through the first tower. Let's see here. For example, cations like Ca2 positive or Mg2 positive, these are present in the hard water. It reacts with RH positive, means this is a cation exchange resin. That exchange reaction it is on. How? Let's see here. R2Ca or R2Mg plus 2H positive. So in this way, that resin it takes calcium or magnesium ion from the water, and it gives this H positive ion to the water. Here again the anions are present in the water. So which anions these are present? For example, SO4 2 negative, CO3 2 negative, Na positive, the cation Cl negative. If these anions are present here, these anions then given out from the resin, because it is having ability to exchange only the cations. So this anion it still remain present in the water, but the cations are completely exchanged. Now let's see here. This is the journey of water through the first tower containing the cation exchange resin. Now what about the further step? You can see after this journey that water it contain H positive ion and these anions from the hard water. Now this H positive react with SO4 2 negative, that water it become acidic. How? Let's see here. In the second step, H positive plus SO4 2 negative ions, there is a formation of H2SO4. Now if H positive react with the CO3 2 negative ion, 2H positive plus CO3 2 negative ion, there is formation of H2CO3 carbonic acid, sulfuric acid. Then if H positive ion it reacts with the Cl negative ion, H positive plus Cl negative, there is formation of HCl, hydrochloric acid. Means that water it becomes acidic. That water it becomes acidic after the journey from the first tower. But that water it become free from the cations causing hardness. Now that acidic water it is allowed to pass through the second tower which is packed with the anion exchange resin. Acidic water we have passed, means that acidic water means H2SO4, H2CO3 or HCl. That acidic water it is percolated through the second tower packed with the anion exchange resin. Now what is the ability of anion exchange resin? It exchanges anions causing hardness from the water. Means it takes SO4 2 negative ion, CO3 2 negative ion and Cl negative ion from the water and it gives its OH negative ion to the water, and that H positive as it is present in the water. Now let's see here about the reaction part. That H2SO4 acidic water, it is percolated. H2SO4, it is percolated through the cation exchange bed. So anion exchange bed. So anion exchange bed is formula is ROH negative. Now what is formed here? There is formation of R2SO4, means that resin it takes SO4 2 negative ion from the water and there is formation of R2SO4 plus what is remained here? 2 hydrogen and 2 OH negative ion. So there is formation of H2O, twice H2O. Now then the next is H2CO3 plus 2ROH negative. If carbonic water it is containing the carbonic acid, so in this case there that resin it takes CO3 2 negative ion from the water. So there is formation of R2CO3 plus twice H2O. If the water it is with HCl, so what about the reaction occurred? HCl plus 1ROH negative. So there is formation of RCl plus H2O. RCl plus H2O. So in this way that resin it becomes R2SO4, R2CO3 or RCl after the exchange of anions from the water, and it leaves as it is H positive ion in the water, outgoing water, and OH negative ion it is added in the water from the resin. Means as a result of this that water it contain H positive and OH negative. Means H positive and OH negative means there is formation of the water. H positive plus OH negative means there is formation of water. Means as a result of this you can see that water it become totally free from cations causing hardness and anions causing hardness. Hence that water it is called as soft water, and that water it is virtually like a distilled water. Distilled water because it become totally free from all the cations and all the anions causing hardness here. Hence that water it is suitable to use for the boiler purpose. Now that about the softening method. Now what is the function of this acid reservoir or the base reservoir? So let's see here. After some time of softening, that resin it becomes inactive or it stop functioning there. It is not able to remove any cations or any anions from the water. Means it stop functioning. Their activity it is lost. So that stage it is called as a exhausted stage. Now that exhausted resins means these resins are costly. Means there is stage to replace this resin by the fresh resin. That state it is called as an exhausted state. But we cannot replace it directly because these resins are costly. So to avoid this, that resins it is allowed to regenerate or reactivate or reclaim. So for such regeneration of exhausted resin, this HCl or NaOH, dilute NaOH or dilute HCl it is used. So dilute HCl it is used for the regeneration of exhausted cation exchange resin, and dilute NaOH it is used for the regeneration or reclamation of exhausted anion exchange resin. So let's see here that regeneration process. So that about the softening process. What about the formula for the exhausted cation exchange resin? Exhausted cation exchange resin means it is either R2Ca or R2Mg or RNA. If the Na it is present in the water as a cation causing hardness, then it is represented as RNA. Now then, exhausted anion exchange resin is R2SO4, R2CO3 or RCl. So these are regenerated by using NaOH. Now let's see here the regeneration. Regeneration after exhausted or after getting that exhausted state for such resins, the flow of the hard water through the column it is allowed to stop, and the flow of the HCl through the first column it is allowed to start. What about here? That HCl react with the exhausted cation exchange resin. Now what is the formula for the exhausted cation exchange resin? It may be R2Ca or R2Mg. So let's see here how. R2Ca or R2Mg plus twice HCl. So there is regeneration, it is occurred. So this is a regeneration. Now there, what about the reaction it is occurred here? Again the exchange. That resin it is with calcium and magnesium ion. That acid it is with H positive ion. So that resin it takes H positive ion from the acid and it gives Ca or Mg ion in the acid. Okay. So let's see here how. 2RH positive plus CaCl2 or MgCl2 means that resin it takes H positive ion from the water, HCl again it is present here. So it takes H positive ion from the water and gives its calcium ion to the water. So that water it contains calcium ion, Ca2 positive ion and chloride ion from the acid. So that water it becomes with, or it is with CaCl2 or again with the MgCl2. So that this is nothing but the formula for regenerated cation exchange resin. And this is a exhausted cation exchange resin. Now what about this CaCl2 and MgCl2? CaCl2 and MgCl2 it is allowed for washing or it is allowed to throw. Completely remove from the column, and that after this that resin it becomes regenerated or reactivated or reclaimed here. Now what about the second, exhausted anion exchange resin? So this exhausted anion exchange resin it is represented as R2CO3 or R2SO4 or RCl. Means that exhausted its formula is R2CO3 or R2SO4 or RCl, and we are passing here what? NaOH solution. So this resin again having ability to exchange. Now what does it exchange here? It gives its CO3 2 negative ion to the water. Water it contains CO3 2 negative ion or SO4 2 negative ion, and at the same time it takes its OH negative ion on itself. And what about that Na? Na it remained in the solution as it is. Now what about the exchange? Let's see here, R2Ca plus NaOH, there is formation of Na2CO3 plus 2ROH negative. Now then R2SO4 plus twice NaOH there is formation of Na2SO4 plus 2ROH negative. RCl plus NaOH, there is formation of NaCl plus H2O. In this way, that solution or that resin, it becomes ROH negative. That resin, it becomes ROH negative, means this, that is about the regenerated resin. And what about the Na2CO3, Na2SO4 or NaCl? It is allowed to throw completely. Means that resin, it becomes regenerated. Anion exchange resin, it becomes completely regenerated. Cation exchange resin, again it becomes regenerated. Now here, after getting this regenerated stage for both the resin, the flow of the HCl solution through the first column, it is allowed to stop, and the flow of the NaOH solution through the second column, it is allowed to stop, and the flow of the hard water through the first column, it is allowed to start. Now that method, it can be carried out as it is. Again the same, that hard water, it is allowed to pass through the first column. That first column, it is able to remove the cations causing hardness from the water, and the second column, it is able to remove the anions causing hardness from the water, and that water, it becomes totally soft, or which is virtually like a distilled water, because it will be free from all the cations and the anions from the water, and that water, it will be suitable for the boiler purpose. So that about the softening method, regeneration of ion exchange resin and softening of the hard water. Now then, what about the advantages or disadvantages of this method? So first advantage means same, that water, it can be used for the boiler purpose, because it is totally free from the cations or the anions causing hardness, or that water, it is just like a distilled water, highly pure water. So two advantages. What is the third advantage? That method, it is simple or easy to operate. It is easy to operate. Then fourth is, the method adjusts itself on variation in hardness. The method adjusts itself on variation in hardness. Means if there is change in the hardness, previously if sometime the hardness is 200 ppm, and for the second batch the hardness is 300 ppm or 500 ppm, means that resin adjusts itself on such variation in hardness, and it will proceed its function. It will proceed that softening process. Okay, that about the advantages. Now what about the disadvantage of this method? First disadvantage is, the resins are costly, expensive. The resins are expensive, highly expensive. Therefore, its wastage, it is highly dangerous. Hence, we have to carry out that regeneration of the cation exchange resin and anion exchange resin. So, this is first disadvantage. What is the second disadvantage? If the turbidity, it is present in the water, if the turbidity, it is present in the incoming water, that water, it is turbid. That turbidity means the dust particle, if clay particle, if some colloidal impurity are present in the water, that is nothing but the turbidity. That turbidity, it blocks the pores on the surface of the resin, and because of this deposition of turbidity on the surface of the resin, that resin stops functioning. So therefore, we non-turbid water, we have to soften, or we have to pass the non-turbid water in the first column or the second column, because that turbidity, it stops the functioning of the resin as this turbidity blocks or deposit on the surface of the resin completely and blocks the pores, and because of that it stops functioning. Hence, if the incoming water it is turbid, that turbidity first of all need to remove by adding any coagulant like alum or sodium aluminate. We can remove its turbidity, and then that water it is allowed to pass through the first column for the softening process. So this is the third. Now second disadvantage. What is the third disadvantage? If the incoming water it contains the colored ions like Mn, manganese ion, and then ferrous ion or the ferric ion, that softening it is occurred, but the regeneration of exhausted cation exchange resin and anion exchange resin, it is very difficult in case of the colored ions. So therefore softening should be allowed here when that water it is free from such colored ions. So these are some disadvantage and these are some advantage. That water it is virtually like a distilled water because it removes both the ions from the water, cation as well as anions from the water. Hence that water it will become suitable to use for the boiler purpose. This is the main advantage of this method. So in this method we have seen the ion exchange method, which is one of the best method for soften the water, and that water we can use for the boiler purpose. Thank you.